Today I am going to discuss duality in linear programming problems. Consider the linear programming problem as to maximize objective function C transpose X subject to the conditions Ax less than equal to V with non-activity restriction, that is X greater than equal to 0, where X is n-dimensional vector, C is n-dimensional vector, V is m-dimensional vector, and capital A is coefficient matrix of order m cross n. Take this LPP as primal problem, then dual of this problem is as dual. If primal is maximization problem, then its dual is minimization problem, and vice versa. Here, to make its dual, the right hand side become the cost coefficients in dual problem, and here we take the transpose of coefficient matrix in dual problem. W are dual variables. Here cost coefficient from primal problem becomes right hand side in dual problem. If variables are non-negative in primal problem, then inequalities in dual problem is greater than equal to type, and if inequalities in primal problems are less than equal to type, then variables in dual problems are greater than equal to 0. This is the dual of this primal problem. It is important to note that there is relationship between the primal constraints and dual variable, and primal variables and dual constraint. What is that relation? That relation is that the number of dual constraints equal to the number of primal variables, and number of dual variables equal to the number of primal constraints. To understand the concept of primal and dual problem, let us make it simple with the help of an example. Consider this problem. Maximize z, objective function as 4x1 plus 3x2, subject to the constraints x1 plus x2 less than equal to 8, 2x1 plus x2 less than equal to 10, x1, x2 both are non-negative. Now, if we want to write this problem in this form, then we write it as maximum z is equal to 4 comma 3 x1 x2. When we multiply this, this becomes 4x1 plus 3x2, and here coefficient matrix is 1 1 2 1, that is 1 1 2 1 with x1 x2 less than equal to 8 and 10, x1 x2 greater than equal to 0. If we compare this with this primal problem, then we get C transpose as 4 comma 3 and coefficient matrix capital A as 1 1 2 1 and x as x1 x2 and small b as, that is right hand side, as 8 and 10. Now we will make dual of this primal problem with the help of this dual problem. Here in dual problem, we first change objective function from maximization to minimization. Here we take cost coefficient as transpose of right hand side of primal problem, and W are our dual variables. Here we take in dual problem transpose of coefficient matrix, then W is our dual variables greater than equal to C. What is C? That is transpose of cost coefficients of primal problem, and W greater than equal to 0. With the help of this, now we make dual. Dual is, as primal is maximization, therefore dual is minimization. Minimize Z star is equal to B transpose. Here in our problem, B is 8 and 10. To take transpose, row becomes column and column becomes row. Therefore, this becomes 8, 10, and as we already discussed that dual constraints are equal to the number of primal variables and dual variables are equal to the number of primal constraints. As there are two primal constraints, therefore there are two dual variables that we let dual variables are W1 and W2. Therefore this becomes 8 comma 10 multiplied by W1 W2 subject to the condition. Here we take the transpose of coefficient matrix. In our case, coefficient matrix is 1 1 2 1. We take its transpose. After taking its transpose, row becomes columns and column becomes rows. This becomes 1 2 1 1. Dual variables are w1 w2 greater than equal. Then we have to take C. In our case, C transpose is 4 comma 3. After taking its transpose, it becomes 4 3 and w1 w2 greater than equal to 0. After solving this becomes dual as minimize of objective function 8w1 plus 10w2, 8w1 plus 10w2, w1 plus 2w2 greater than equal to 4, w1 plus 2w2 greater than equal to 4, w1 plus w2 greater than equal to 3, w1 plus w2 greater than equal to 3, w1 w2 both are non-negative. This is how we make dual of a primal problem. We make dual of primal problem directly. Say here, assume dual variable w1 corresponding to this constraint and dual variable w2 corresponding to this constraint. Then our dual become minimize z star 8w1 plus 10w2. 8w1 plus 10w2. That is, our right hand side becomes cost coefficients in dual problem. 8w1 plus 10w2 subject to the constraints w1 plus 2w2, w1 plus 2w2, then w1 plus w2, w1 plus w2. As here, if variables are greater than equal to 0, then inequalities in dual problems are greater than equal. Therefore, greater than equal, greater than equal. Now, its cost coefficient becomes right hand side in dual problem. Therefore, here coefficient, first cost coefficient is 4. Therefore, we write here in first constraint 4. Here second cost coefficient is 3. Therefore, we write in second dual constraint right hand side as 3. And as inequalities are less than equal to 0, if inequalities are less than equal to type in primal problem, then dual variables are always greater than equal to 0. Therefore, w1 w2 greater than equal to 0. Either we make dual by going to this process, or we make dual by directly importing dual variables corresponding to the primal constraints, and then we write dual as directly I have discussed earlier. Earlier we have discussed that if all the inequalities in primal problems are of less than equal to type, then how to write dual of this type of problem. This is the way how to write dual of problem where all inequalities are less than equal to type. Now we take the second case, that when all the inequalities are of greater than equal to type. Consider the second case. Here, to primal problem as maximize objective function z is equal to c transpose x subject to the condition ax greater than equal to b with non-activity restrictions x greater than equal to 0. Now here in this case, all the inequalities are of greater than equal to type. Now we discuss how to write dual in this case. First we rewrite this primal problem as this: maximize objective function z is equal to c transpose x. We multiply all the constraints of greater than equal to type with negative sign. After multiplying with negative sign, it becomes minus ax less than equal to minus b with non-activity restrictions. Now we write its dual with the help of this. In the same way, we take, as primal is maximization problem, therefore its dual is minimization problem. And here, as in this case, here we take in dual transpose of right hand side. Therefore, same here, we take transpose of right hand side in dual problem, and u is our dual variables. Here we take transpose in dual. Therefore, we take transpose of this coefficient matrix in dual minus A transpose. U is our dual variable greater than equal to, here C is our C is cost coefficient in primal problem and it becomes right hand side in dual problem. Inequality signs are same as all constraints are less than equal to type, therefore dual variables are greater than equal to type. All variables in primal problem are greater than equal to type, therefore all dual constraints are greater than equal to type. Same here, as all dual variables are greater than, as all primal variables are greater than equal to 0, therefore all dual constraints are greater than equal to type. And all primal constraints are less than equal to type, therefore all dual variables are greater than equal to type. Now here we put w is equal to minus u, then we rewrite the dual, then it becomes minimize z star is equal to, here we put u minus u equal to w, therefore this becomes b transpose w, and it becomes a transpose w greater than equal to c, because u is greater than equal to 0 and we put w equal to minus u, therefore w becomes less than equal to 0. Therefore if in second case all inequalities in primal problem are of greater than equal to type, then all dual variables are less than equal to 0. Corresponding to primal constraints, we decide the sign of dual variable, and corresponding to primal variable sign, we decide dual constraints sign. As here all primal variables are greater than equal to 0, therefore here all dual constraints are greater than equal to type. And here as primal constraints are greater than equal to type, therefore all dual variables are less than equal to 0. Therefore, if all the constraints in the primal problem are greater than equal to type, then all the dual variables are less than equal to 0. We have already discussed two cases that if all the inequalities in primal are of less than equal to type, then how to write dual, and in second case we discussed that if all the inequalities in primal problem are of greater than equal to type, then how to write dual. Now we discuss the third case, that if all the inequalities in primal problem are of equal type, that is there is equality in all the primal constraints, then how to write its dual. First we rewrite this primal problem as we maximize z is equal to c transpose x. Here as constraints are of equality type, we divide into two constraints. One is of the type ax is less than equal to type, and second is ax greater than equal to b. We split this constraint ax equal to b into two types of constraints. First is of the type less than equal and second is of the type greater than equal. Now we multiply this second type of constraints with negative sign, then it becomes minus ax less than equal to minus b. That means we rewrite this constraints ax equal to b in the form like this: ax less than equal to b and minus ax less than equal to minus b. Now we rewrite its write its dual as, let us take corresponding to this type of constraints we take dual variable u, and corresponding to this type of constraints we take dual variable v. Now it becomes, as primal is maximization problem, therefore its dual is minimization problem, and it becomes right hand side becomes cost coefficient, therefore it becomes b transpose u plus minus b transpose v, and we take transpose in dual as a transpose u plus minus a whole transpose v greater than equal to, cost coefficient in primal problem becomes right hand side in dual, therefore it becomes greater than equal to c. As both the inequalities are of less than equal to type, therefore in first case we discussed that if inequalities are of less than equal to type, then dual variables are greater than equal to 0. Therefore both dual variables u and v greater than equal to 0. Now we rewrite it as minimum z star equal to b transpose u minus V transpose V subject to A transpose U minus A transpose V greater than equal to C. U and V both are non-negative. We put U minus V as a new dual variable W. Then it becomes, if we take V transpose here common, then this becomes V transpose into U minus V, which further becomes V transpose W, and it becomes A transpose W greater than equal to C. Now, as U and V are greater than equal to 0, we can't decide the sign of W. W is U minus B. If U and V greater than equal to 0, we can't decide the sign of W. It is negative, it is 0, it is positive. Therefore, here in this case, W is unrestricted. That means if all the constraints are of equality type, then corresponding to that constraints, always dual variable is always unrestricted. We have discussed all the three cases that how to make dual if inequalities are less than equal to type, if inequalities are greater than equal to type, if constraints are of equal type. Now we put this information in the form of table. This is rule table for construction of dual. Let us take primal as maximization problem and dual as minimization problem. Now if inequalities are less than equal to type, then dual variables are greater than equal to 0. Here, if ith constraint is less than equal to type, then ith dual variable is greater than equal to 0. Here in second case, we discuss if inequalities is of type greater than equal to type, then dual variables is less than equal to 0. Therefore, we write this: if ith constraint is greater than equal to type, then ith dual variable is less than equal to 0. In third case, we discuss if constraints is of equal type, then dual variable is unrestricted. Thus, we put here, if ith constraint is equal type, then ith dual variable is unrestricted in sign. Now we write this information also. We write this information that if jth dual variable is less than equal to 0, if jth primal variable is less than equal to 0, then jth dual constraint is less than equal to type. If jth primal variable is greater than equal to 0, then jth dual constraint is greater than equal to type. If jth primal variable is unrestricted, then jth dual constraint is of equality type. If we have primal as maximization problem, then to make its dual, we move from left to right in rule table. And if we have primal as minimization problem, then we move from right to left in rule table. Now we will discuss how to make dual of primal problem with the help of examples. Now we discuss how to write the dual of this following LPP. Now, because this problem is of maximization, therefore our primal is maximization problem. Now we have to write its dual, that is minimization problem. Because primal is our maximization problem, therefore we move left to right. Now, as primal is maximization problem, let's take as primal. Primal is maximization problem, therefore its dual is minimization problem. Dual is minimization problem. Let's take W1 dual variable corresponding to first constraint, W2 dual variable corresponding to second constraint, W3 dual variable corresponding to third constraint. Now right hand side becomes cost coefficient. Therefore objective function becomes 10W1 minus 8W2 plus 9W3. subject to the constraints. Now we take the transpose of coefficient matrix. We write directly W1 1 into W2 plus 1 into W3. This becomes W1 plus W2 plus W3. The second constraint is 1 into W1 minus 2 into W2 plus 3 into W3. 1 into W1 minus 2 into W2 plus 3 into W3. Now, right hand side comes from cost coefficient. First cost coefficient is minus 2. Therefore, we write minus 2 in first constraint. Second cost coefficient is minus 1. Therefore, we write minus 1 in second constraint. Now, W1, W2, W3. Now, we have to decide the sign of these constraints and sign of these dual variables. Now we first decide the sign of these dual constraints. Now we know that the sign of dual constraints come from the sign of primal variables, and first primal variable is greater than equal to 0. If primal variable is greater than equal to 0, then dual constraint is of the type greater than equal to type. Therefore first constraint is of the type greater than equal to. Now second variable is second primal variable is unrestricted. If primal variable is unrestricted, then that constraint is of equality type, because second variable primal variable is unrestricted. Therefore second dual constraint is of equality type. Now we decide the signs of dual variables. We know that the sign of dual variables can be decided with the help of primal constraints. Now first primal constraint is of less than equal to type. If primal constraint is of less than equal to type, then dual variable is greater than equal to 0. Therefore W1 is greater than equal to 0. Now second primal constraint is of equality type. If primal constraint is of equality type, then dual variable is unrestricted in sign. Therefore W is unrestricted in sign. Now third constraint, primal constraint is of greater than equal type. If primal constraint is greater than equal to type, then dual variable is less than equal to 0. Therefore W3 is less than equal to 0. Therefore this is the dual of this primal problem. Therefore with the help of this rule table, we can write the primal of dual problem like this. We write the dual of this primal problem. Now we write the dual of this following LTP. Now because the problem is of minimization, we take primal as minimization problem. Therefore if primal is as minimization problem, then we move from right to left in our dual problem in order to make dual problem. Now we write its dual, because our primal is minimization problem, therefore its dual is maximization problem. Say we let W1 is dual variable corresponding to first primal constraint, W2 is dual variable corresponding to second primal constraint, and W3 is third dual variable corresponding to third primal constraint. Now as we know that right hand side become cost coefficient, therefore it becomes 8W1 plus 1W2 plus 9W3 subject to the conditions. Now we take the transpose of coefficient matrix. It becomes 2 times W1 minus W2 plus 1W3. 2W1 minus W2 plus W3. The second is W1. Here X2 is missing. Therefore 0W2, 2W3. W1 plus 0 times W2 plus 2W3. Next, minus W1 plus plus W2 plus 3W3. Minus W1 plus W2 plus 3W3. Now we know that cost coefficient becomes right hand side. First cost coefficient is 2. Therefore we write 2 here. Second is minus 1. We write minus 1 here. Third is 1. We write 1 here. Now we decide the sign of dual variables W1, W2, W3 and the sign of dual constraints. Now first we decide the sign of dual constraint. Now first primal variable is greater than equal to 0. If variable is greater than equal to 0, then corresponding to variable greater than equal to 0, constraint is of the type less than equal to type. Therefore first constraint is of the form less than equal. Second variable is greater than equal to 0. Again, if variable is greater than equal to 0, then constraint is of the type less than equal to type. Therefore less than equal. Third variable is unrestricted in sign. Therefore, if variable is unrestricted in sign, then constraint is equality type. Therefore, we write equality here. Now we decide the sign of dual variables W1, W2, W3. Now, as constraint is less than equal to type, if constraint is less than equal to type, then dual variable is less than equal to 0. Therefore, W1 is less than equal to 0. Second constraint is greater than equal to type. If constraint is greater than equal to type, then variable is greater than equal to 0. Therefore, W2 is greater than equal to 0. Third constraint is equality type. If constraint is equality type, then variable is unrestricted. Therefore, W3 is unrestricted. This is the dual of this primal problem. Therefore, we can make dual of any LPP with the help of this rule table. If primal is maximization problem, then to make its dual, we have moved from left to right in rule table. And if primal is minimization problem, then to write its dual, we have moved from right to left in rule table. Therefore, in this way, we write the dual of any problem with the help of rule table.
Friends, if you like this video, please subscribe our channel. Then press the bell icon button to get new notification of our new videos. Thank you, friends.